Welcome to calculating atomic weight. So first, we know that we can use atomic mass units for convenience. And so a lot of times we said that the mass of individual atoms are very small. And so the hydrogen atom has a mass of only 1.6735 times 10 to the minus 24th gram. Oxygen is small as well. And so one of the things that we can do, and we said that chemists do, is we use this one atomic mass unit, and we can use this conversion factor to go from grams to atomic mass units. And so essentially what we're saying is that we could take this 1.6735 times 10 to the minus 24th grams and convert it to atomic mass units, because what we know is in one atomic mass unit, there is 1.66 times 10 to the minus 24th grams. And so in this case, our grams cancel, and we're going to be left with atomic mass units. And for hydrogen, this would come out to 1.0078 atomic mass units. Thus, we can convert it directly to atomic mass units. We could do the same thing for oxygen, where we take the oxygen mass in grams, and then we could convert that to the mass in atomic mass units using that same kind of conversion factor. This really just makes it a lot easier to work with. So whenever we talk about atomic weight, we're talking about the average atomic mass. And that's because a lot of elements occur in nature as some kind of mixture of isotopes, meaning that maybe you have something like carbon-12, which makes up about 99% of all the natural carbon found in the atmosphere. And it has a mass of 12 atomic mass units. But there's a small percentage, about 1%, that exists as carbon-13. Thus, it has a mass of 13 atomic mass units. And so we talk about atomic weight, or like I said, the average atomic mass. And so really, anytime we talk about these are really the same thing, atomic weight or average mass. It's taking the average atomic masses of each element found in nature. And so in particular, we could look at carbon, where we know that 98.93%, which we now convert to a decimal, times its atomic mass, 12 atomic mass units. We could then add that to the other isotope, which is about 1%, which now we get rid of the percent sign by dividing by 100, and then we can multiply it by the atomic mass units for the carbon-13 atom. And what we do is we get the average atomic mass, or the atomic weight. And what we find is 12.01 atomic mass units. Well, this is exactly what we see on the periodic table, where we calculate it, and this is where this number comes from. It comes from the average atomic mass. It's an average of all the different isotopes that exist. So that's really it for atomic weight, or average atomic mass. We're just taking the average mass of all the different isotopes. So this concludes the how-to on atomic weight calculations.